Hello and welcome to my YouTube channel. In this video I am going to discuss about my final year research project. I have done masters from NIT Silchar in computer science and engineering. My work is about in a video detecting the cut transition. So I will explain about everything of my video. Let's pay attention and you will understanding whatever I have done my work. I have done quite good work, so I got 10.0 in my final semester. I haven't published any research paper on it, so it made me quite risk to do that. But I don't care. I am putting myself my work by what in a simplest way, whatever way I can do, I will do. So please watch. Suppose a video. A video is collection of what? Images. That images we call as frames. Suppose in a video like 30 frames per second, 40 frames per second, there are consecutive frames you are watching. Okay, you are not watching any video like video as such any independent entity. You are watching consecutive frames. So these are frames. Okay, so I have done machine learning in this my big project. So first we are what we do is uh, first we are extracting one video frame. One is not video frames and calculating the textures from it. Actually, sub video is a collection of image is a collection of what? Collection of pixels. Okay. Say this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Okay. This is a texture matrix. Actually texture is calculated by GLCM, gray level co-occurrence matrix. Okay. We are trying to detect what I will say it afterwards. First understand what is GLCM. Okay, some image will be there. That is not image. The image I am showing. Okay, image. This is image. 1 2 1 2 3 1 2 1 2 1 3 2 4 3 4 3 2 1 2. Okay, so now you can see that 1 2. This portion you see 1 2 1 2. There is one time 1 2 again and 1 2 again. So three times we are getting what? 1 2. So similarly 2 1. 2 1, how many times we are getting? This that time. And 2 1 is not there, I think. 2 times. So this is the texture. This is the this is the 0 degree texture. We are calculating how many degrees? 0 degree. We are calculating 0 degree, 45 degree. So much degree other than this is possible. That is the texture of my gray level co-occurrence matrix. Okay. After that, okay, GLCM is calculated. GLCM is after calculated of GLCM. We are This is the second order statistical features, right? Second order statistical means one, two elements we are considering, na? So that's why it is second order statistical. Why statistical? We are not considering any point, right? Any point is meaningless. By 0 degree that or 45 degree we will consider the 4 1 will be given here. So that's why in 0 degree we are calculating. So this is a statistical feature. So for these statistical features we will contrast. The equation I will not give. Equation will be is confidential. It will be in my thesis work only. Contrast, correlation, homogeneity, Okay, these four features we will extract. After that, what we will do? After that, we will train a then machine learning portion comes. So machine learning, I will discuss some basics beforehand. After that, you will understand fully what I am going to say. Machine learning means there are two types of machine learning. One is uh, deterministic, one is stochastic. Okay, deterministic mainly back propagation or there back propagation. Some, if you have some of the learning, you will that you will understand that actually in the neurons there will be some error, and error will be back propagated to previous level and some level. And stochastic is different, like optimization algorithms. Obviously we are using supervised learning approach, that is not unsupervised learning. We will be using the data previous and supervised. And difference between those two is, in supervised we are having data previously, we are feeding the network, we are training the network by data, external data. And unsupervised means we will be not having any external data, the training will be done by itself. That is somewhat difficult to do here. So we are using what? Supervised learning. Supervised learning. Okay. So what will be there? Actually, some I have to erase it. Okay. Erase it actually 1, 2, 3, 4, 5, 6, 7, 8, 9. And 1, 2, 3, 4, 1. That is the structure of our network. 1, 2, 3, 4, 5, 6, 7, 8, 9. And again 1, 2, 3, 4, 5, 6, 7, 8, 9. And again 1, 2, 3, 4, 5, 6, 7, 8, 9. And again 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, these are the weights. These are called weights. Actually, these are called what? Actually, from human brain it has evaluated. The scientist has given the names by evaluating human brains. These are the neurons. Okay, how many neurons are there? 4 input neurons and 9. 2 into n plus 1. The formula is that. That is why we have used it. And 1 output neuron. That is cut or not. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So sorry. Okay. So these are the input neurons. So in these neurons we are going to give the features. Like we have some training videos. We will extract the frames from what is the transition. We are going to actually in this project we are going to detect what? In a video there is a collection of frames. We are going to detect the transitions. What are the abrupt transitions in it? We are going to detect that. So for that we are going to have some test training videos. In that videos we are going to have some transitions. We are edited some transition manually, and this is the in this between this is the transition frame, and that we are going to feed here. Okay, after feeding here there will be a hypothetical function here we will get a hypothetical function, theoretical functions, whose means the that functions input will be weights and biases. Weights, what? These are the weights w, these are the weights. Okay, these are the weights, means 4 into 9, 36 are there, plus here the weights will be weights. For how many weights? 36 plus 9 means 45 weights, and biases 4 plus 9 is equals to 30 plus 1 14, biases 14. Okay, from one neuron itself a bias will be given. These weights and biases will be determined by the what? The input means correlation, contrast, that features we have extracted, that features we are now going to put here, homogeneity and energy. Okay, that weights and biases will be given, and after that the hypothetical function will be constructed, and we will be getting here the optimization, that these will be optimized, and from this we are getting output as a hypothetical function. Output is cut or not, means transition is cut transition or not. So optimized means gray wolf optimization, and hybridized, we hybridized it, Cuckoo search algorithm we have used it, and from that gray wolf optimization and Cuckoo search we have used it. Okay, and this is the hypothetical function. So this is the what? First step of our research. This is the main step. This is the main step. What we are do, we will training. There is the training phase. Training phase is what? Training and testing videos. Some videos are training set. Some videos are there for training purpose, and some videos are there for testing purpose. So in training phase we have trained the network with 10 videos, 10 cut frames. We have developed the transition of 10 cut frames. Then we have trained it, and after that testing. The testing we have taken 11 videos. Okay, and from that we have mainly some three things are there: precision, recall, and F1 score. If I have to discuss for that also, it will be more lengthy. Videos will be mainly more lengthy. So it is morely we have I have will be focusing on recall, not precision. That will be false negative. I have focused that every transition we are covering, no transition is left out, because in the first stage we are just detecting the transition which are needed, means which are truly there. Okay, in the second step we are actually detecting the transition precisely. First, the recall is important. For the first step, recall is important. We are seeing that recall is good or bad. After the first step, saying the second step, precision is important. How precisely we can detect the transition. Okay, okay. This is over. I think first step is over. First step we are got what is there, and after that, first step is over. After that, recall. Recall is there. How many recall means? I will explain you. true positive by true positive plus false negative. False negative means what? Negative means what? That is not there. False negative means that is negative but false, means we are missing the transitions which is actually there. We are missing the transition. That thing should not be happening. Okay, so recall value is increasing with the false negative. If false negative is more, then recall value is decreased. So in the first step we have confidence, we are covering all the transitions or not, that we are seeing. Okay, after that second step is trivial, nothing is there. Second step is just, we have got the transitions, right? We have got the transition from the feed forward neural network. And then suppose we have got 77 transitions. After the 77 transition, we will take it and apply to thresholding, apply thresholding in it. So what is thresholding? What is thresholding? Thresholding means some so all the transition will have some I think LBP. We will extract all the features and separate features from all the frames, and suppose we have transition value is 789.283.593, like that. We have all the points. Now we will apply one threshold, means above this whatever is there will be eliminated. Threshold equals to 0.4. If I do this, so this will be eliminated, this will be eliminated, this will be there. So that is thresholding, nothing else. So we have to check the threshold value. That we have done. We are increasing the what? Precision. Precision is what we are increasing. We are concentrating on recall in the first step, and after that precision. So what will increase? F1 score is increase. So I think you know about F1 score. F1 score is precision into recall and by precision plus recall. Okay, F1 score will increase. So by thresholding itself, F1 score has increased, and that is the main procedure. So thank you. I think you have understood it. First, I think the feed-forward neural network is the main step that we have to understand, and second step is trivial. Just one more thing. Selecting threshold is a challenge, right? We have to select threshold in such a way that more precise transitions will be there. Means if we select threshold much more, then what will be happening? All the threshold will be, all the things will be there. Means all the transition we will get and nothing will be eliminated. If we threshold in very less, so what will happening? Some true positive means which is true transitions, cut transition, that will be eliminated. So we have to select threshold in such a way that we will get precise output. So that is done by experimental purpose. Adaptive threshold, that is the process is adaptive threshold. That thresholding is a challenge. So by that thresholding we will get more precision. So F1 score is increased. So we have compared with various methodologies. Our methodology is better. We will getting much more accuracy by this. This is the main step, and thank you for watching.